Thank you very much, Lewis. Yeah, so this talk is aimed at downstream packages, so Linux distributions, people making Conda packages, Spack, anybody who's trying to take Python packages and put them into some other packaging format in particular. From the talk just before the break, it sounds like Red Hat already know all of this and don't need this talk, but possibly, perhaps not everybody is as up to speed as they are with the latest changes in Python packaging. And just to be clear, like, what I'm going to be talking about should be mostly invisible to end users of Python packaging. Like the tools like pip should take care of these things for you. So I'm going to be kind of talking about how to go underneath that layer if you want to build your own packages. So briefly, a bit about me. Who am I and why am I telling you about these things? I work in scientific computing as my sort of day job, particularly scientific Python. So I'm working at European Exfil, which is a big science facility just outside Hamburg. So X-ray, free electron, laser, for those who are interested in that sort of thing. In the past, I've worked on IPython and Jupyter, and at the moment, like probably the most prominent open source thing that I'm involved with is H5Py, which is all kind of within the scientific world. Packaging is a side interest, but it's useful often enough in my day job that European Exfil has paid my attendance fee for the conference. I made Flit, which will appear in the talk a bit later on. I've been involved in some of the PEPs to standardize these different packaging tools and how they work together, particularly PEP 517 and PEP 621 I'm named as an author on. I've also worked a bit on application packaging. I made a tool called PyInsist, which is not really going to come up today, but it's another interesting bit of packaging stuff. And my username or handle is TA Kluyver on most things that there are in the sort of developer-oriented world. I'm pretty easy to find online if you want to talk to me. So, many years ago, Python packaging was simple. You got your source code, you ran a command like setup.py install, and it got installed on your computer. And if I skip over a whole lot of complicated history, this is roughly what a setup.py file looks like, and with some minor changes to what you import, pretty much what it has looked like since these tools were first a thing, which I think was about 20 years ago. I wasn't really there. So your setup.py ideally just calls this setup function with a whole load of keyword arguments for metadata. In reality, it often ends up being at least a bit more complicated than this, but this is kind of the platonic ideal of setup.py. And then setup tools is responsible for implementing that install subcommand that we saw and any other subcommands that are going to come up. So you just kind of like hand over this metadata to setup tools and it decides what to do with it. Of course, packaging isn't really that simple. People want things like package indices and dependencies getting automatically downloaded and installed. And so lots of tooling and package formats sprang up around this. So this slide is kind of the present / past. This is the situation as of roughly 2013, and this is still kind of how it can work today. So we've still got the direct route. We can still do setup.py install on our source code to go directly to an installed thing. We can also turn the source code into an sdist. So this is a source distribution, a tarball, which kind of ideally contains all of your source code, including things like tests and documentation sources. And that you can unpack just as an archive to get sort of a variant of the source code back. And you can run setup.py install from that to go to an installed distribution. I've changed the logo for the installed thing here to a folder to represent that you can have that. That can now be a virtual env, not, you're not just always doing global installs onto your system anymore. And then from 2013, we've also got this wheel format. So if you do setup.py bdist wheel, it will build a .wool package, which is really a zip file. And this contains a pre-built package. So unlike setup.py, and unlike source distributions where installing them is still defined by this setup.py format, wheels have a standard layout, and there's kind of a documented way to go from a wheel to an installation, which is pretty much like unpack these files in these places. There's a little bit more to it than that, which I will get to later on. But yeah, the idea is that the wheel is very much like the standardized documented package format, and there is a standardized documented way to extract a wheel onto your system to install that. And the name wheel comes from wheels of cheese. So this is a part of an old joke wherein PyPI is referred to as the cheese shop from the Monty Python cheese shop sketch. And this is kind of what we're aiming for, and to some extent what we've already got now, that we've taken out that direct install, we've taken out installing directly from an sdist, and the only way in this kind of future / present variant is to install from a wheel. So a wheel kind of represents our relocatable install in a sense. Like you build a wheel and that contains everything that is going to be installed, and then the installer is just deciding where you put it. So everything that gets installed is going via wheels at some point. And so if you ask pip to install something from source, either by pointing it to a directory on your computer or a Git repository, or saying like, get this from PyPI, but don't fetch the wheel because I don't want to use that wheel for whatever reason, then pip will actually transparently build a wheel behind the scenes for you and then install that. And as part of this, there is also a standard interface to make the wheels. So setup.py bdist wheel is now just one possible implementation of that standard. And this is already how things work for packages that have moved away from setup.py. For packages that still have setup.py, it will try to work this way, and if something goes wrong, then it will fall back to doing setup.py install for the time being. At some point within the next probably couple of years, that fallback, I think, will go away. So you may ask, why are we changing stuff? Wasn't what we already had working well enough? And there's a variety of reasons why people weren't happy with what we had. So one big one is that people want alternatives to setup tools. It's not the ideal build system for every package by quite a long margin. A lot of people look at the tooling that other languages have and say, why can't we have these nice things in Python as well? And so you get things like Poetry, which are created to meet that demand. Python also has some very complicated packages, like, PyPI. The Python packaging ecosystem really has to span the range from, 20 lines of utility code that you put in a little package and stick on PyPI in 10 minutes, up to things like SciPy, which require C compilers and Fortran compilers and a whole load of sort of supporting libraries to build. And setup tools kind of can do that kind of level of complexity, but it's really quite awkward to make it do that, and people would like other things. Setup tools itself can't easily change. There's a whole load of backwards compatibility it has to maintain, and up until these changes that I'm talking about, the only option for not using setup tools was to basically pretend to be setup tools. So we had implementation defined behavior. We also want to make installation more reliable. So there have been a bunch of bugs in the past where files weren't included in a certain type of package. So if you installed something directly, it worked. But if someone made a package and then you installed that, it didn't work. So the idea is that we'll cut down on the number of different pathways there are to get something installed, force everything to go through wheels. This makes bugs with the packaging process more obvious because everybody's going through the same pathway. So those things should get fixed quicker. And as virtual envs became the norm, then executable install scripts that sort of reach out onto your system and say, like, oh, I'll put a start menu shortcut here or some documentation files there or whatever, are not what we want, because we want to nicely constrain the installation into these virtual envs. So the new kind of linchpin of packaging information in every project is going to be this pyproject.toml. A lot of projects are already using these. They're obviously projects that don't have these still kind of have to keep working, so it's not really ever going to be every project, but hopefully over time the majority of projects will have this kind of file. And this is telling us a few things. So the requires line is telling us what to install to build this. So it's telling us what the build system is, and then there is a way for it to query the build system to ask for any extra requirements. The build backend line is pep517. This was kind of the really core piece of this change, and this took sort of 600 messages on a mailing list to hash out exactly how this interface would work. But this tells a tool like pip, what should I actually talk to get this package built? And then the project table with the metadata is a more recent standard, PEP 621, for having kind of a standard layout for this metadata within a pyproject.toml file. And there's also room for tools like Flit to have their own tables. So any package on PyPI can define kind of its own tool.whatever namespace for extra information. So if we don't have setup.py, what are we going to call instead? So setup.py install, you call pip install dot instead. And that's, that one's kind of very much standard. That's a user-focused thing. The rest are all kind of more developer-focused things. And so there's there's kind of an easy answer, which I've put here. So for making packages, you can use this build package. For uploading things, there's Twine, but tooling like Poetry and Flit will have their own equivalents of these that developers can use for more convenience. And then some people wound up using setup.py as a kind of generic command runner for things like tests and documentation, which is one of those weird things where some people think that it's like what everybody ought to use, and other people are completely unaware of it. But these things are probably going away at some point, and there are alternatives, but not kind of one thing that will work for every project on those. So we have a number of build backends and front ends. So front ends are the things that the package consumer uses, like pip or tox. These are things that you're actually typing in your command line directly, and the front end will ask the back end to make a wheel with the standard API defined by PEP 517, and the back end is the bit that's chosen by the package maintainers. So that's what the metadata in the package in the pyproject.toml file is telling the front end which backend it should use. So pip is a user-focused tool, and it does a whole lot of things within one big package. We're aware that's not ideal for people sort of building packages for different packaging ecosystems. So build and installer together are these pair of lower level tools that you can use for your packaging workflow. The idea is that build goes from the source code to a wheel, and installer goes from the wheel to the installed files ready to be used. I can see that I'm a bit short on time, but I'm also getting to the end of the slides, so we will get there. So build you run with python-m build. This is a front end in PEP 517 terms. So even though it's a low-level tool, it will still by default make a build environment, install your build backend and any other build dependencies. If you don't want it to do that, if you want to provide those things yourself, you use this -- no isolation flag. And then installer unpacks the wheels, creates command line entry points, and writes the package installation metadata. So these are the kind of extra bits that I mentioned when it said on the slides, unpack wheel asterisk. These are the extra steps that you need to get something fully installed. So the command line entry points, the scripts, are things like pip, IPython, Black, anything like that, where you want to be able to type a command at the shell to launch this thing. They have to be created as a separate installation step. So if you want to install from source with no automatic management of build dependencies or anything, this is what you would do. Install build, the appropriate build backend for the package, so something like Flit Core or Setup Tools or Poetry Core, and any other build dependencies that are required, which might be dynamically specified. There can be extra build dependencies coming from the backend and the package. They don't all have to be in the pyproject.toml file. Get the source of the package, run this python-m build command to create a wheel, and then use installer or pip to unpack that and do the installation. And I think I will skip this bit and take questions if there are any.
Thank you, Thomas. Yes, we do have questions. Our first question is, would the project table in pyproject.toml replace the tool-specific metadata that exists now? For example, entries in tool.poetry table?
I think that's the idea, and certainly for Flit, that's what I'm doing, that the tool.flit.metadata table will over time go away and be replaced by this project table. It's up to each sort of packaging tool like Poetry what they want to do with that, whether they support both indefinitely, whether they even support the new one at all. But I think that's probably the direction we're going to go in.
Cool. Our next question. If you are removing support like setup tools, how many packages will get dropped out from Python ecosystem? Do you base your support removal on usage or just your own preferences? Do you have usage stats? It's missing on the question.
So we're not removing support for setup tools or anything. So setup tools is a build backend within this system, and tools like pip know it as the default build backend. So if you don't have a pyproject.toml file, or if you have a pyproject.toml file that doesn't specify what build backend you're using, then pip will assume you're using setup tools. Obviously, packaging transitions, like there's always going to be some corner case that you break, but in general, we're not breaking things like this. This should be transparent for things using setup tools. They should keep working. Setup tools is not going away.
Cool, thank you. Our next question: what's the future of editable installs, like pip install -e dots?
That's a very well-timed question because there has just recently been a PEP, which I believe is PEP 660, which essentially standardizes how editable installs work. So for systems for backends that support this, including Flit, thanks to some work by the author of PEP 660, pip install -e dot now works with the new standards.
Cool. Next question. Do you or anybody else know if Debian tooling dealing with TOML is coming? Right now, TOML only upstreams are unpackagable because DHPython, the Debian tool that calls into setup tools, etc., does not support it.
That's an easy one. I do not know.
Okay, so let's go for our next question. How to deal with user expectations that Python setup.py install can be used? Will there be some standard boilerplate setup.py that calls new tools based on pyproject.toml?
At the moment, it kind of seems like no. So Flit for a while generated, actually still does generate a setup.py when you publish a source distribution to pypy. But I think in the majority of cases, users are already using pip install to get packages. And yeah, like certainly there are some people who expect that setup.py install works. My feeling is that we're just going to break that expectation and have people get used to newer ways of doing things. And even within setup tools, like you can now have a setup.cfg file without a setup.py.
Okay, thanks. There was an answer on the Element channel that there is ongoing work in Debian to support PEP 517 and pyproject.toml, so now we know. And that's it, what we have for questions. Thank you very much, Thomas. And
thank you.
See you around.